Okay, John, I see you got the hood up and we've just returned from a drive. The engine's nice and hot. What happens next?
Well, what happens next is, because the oil change interval typically falls on to when you're doing a tune-up, while the engine's good and hot, this is a great time to start draining the oil, remove the oil filter, and go ahead and rerun the valves with the hot lash. Everything's nice and hot and you're ready to go. And by the time you get done relashing the valves hot, now you're ready to start putting the oil back in, and we can get busy on the electrical side of this. If when we were out on the drive, if I felt that any of the cylinders were not running as cleanly as they should, at this point I would, after I did my hot lash and I put oil back in the engine, I would run a compression check using a gauge somewhat like this one. I always find it's easier to have an adapter that comes loose from the gauge so you can put it in easily into where the spark plug was. When you're running a compression check, block the throttle valve on the carburetors open and make sure all 4 spark plugs are out. Otherwise it won't be an accurate compression check. Once we've got the valves run, we've got oil back in the engine, we got a new oil filter on, we finished the mechanical side, and now we're getting ready to get started on the electrical side. Most MGs came from the factory with a point ignition, and in fact the bulk majority of MGs, MGAs, midgets all had a 25D4, and I also believe the 25D4 was used on most Triumphs as well. So it's a very common Lucas distributor, very simple distributor. It's also easy for people to mess up when they're putting new points in it. I will have to admit that after changing points on MG engines for about 38 years, I finally decided I was going to put electronic ignition in, and we'll talk about that after we talk about what you need to look out for on a 25D4 distributor. What we're seeing is that the points inside the distributor cap are kind of dirty and need to be cleaned. And if you look closely at the rotor, it's not shiny bright brass, but it does look like an original Lucas rotor. By the way, if you have a Lucas rotor, keep it. The aftermarket rotors that they're selling for Lucas distributors these days, unless you get one from Jeff Schlemmer at Advanced Distributor, are junk, because he after fighting the problem has gotten has started building really good rotors for these. Okay, I'm going to pull this rotor off. The other thing you need to think about is there's a mechanical advance. So if I hold the bottom of this distributor and rotate, it should be free. If it's solid, then you need to disassemble the distributor and clean it so it'll move freely. It's a good time right now to put a couple of drops of oil in here, and this one's missing the cotton that was originally in there to hold the oil. So, but putting a couple of drops of oil in here and putting the cap back on, it'll be fine.
What?
And if you look very closely here, I'm hoping you can see there's a piece of plastic between this nut and the wire going to the coil and the wire going to the condenser. I cannot tell you how many times when I was working at an MG Jaguar dealership, I had guys that said they worked all weekend tuning their MGs and they wouldn't run, and they had them towed in, and the minute you pull the distributor cap off, you see they've got the condenser wire and the coil wire underneath the nut, not underneath the insulator, which grounds it out. So that's the critical part. The other thing is, a 25D4 likes 60 degrees of dwell. And I guess, let me explain dwell to you for just a second. Dwell is the amount of time the points are closed, okay? And dwell is the amount of time that the primary coils in the primary windings in the coil get energized. When the points open, that's when the field collapses into the secondary windings and you get a spark, okay?
Excellent.
So when you set these, set a 25D4 at 15 thousandths gap on the points, but back it up with checking with your dwell meter to make sure you got 60 degrees. Because as the point plate wears, as the little arm wears on the points, it'll change. And so you're always looking for 60 degrees. If you have a later model MG that has a 45D4 distributor, you want 51 degrees. And same point gap, but it's 51 degrees of dwell instead of 60. Okay. A lot of people have said that that MGs always came with a terrible electronic ignition. This is not the case. If you see a distributor in a 76 or newer MGB or midget, and where the vacuum advances, it's got a big square block that's got some green looking plastic on it. That's called the Opus ignition, but we always called it the hopeless ignition because it truly was bad. This is a CEI ignition, or constant energy ignition, and it had the electronics moved to a separate box that then connected to a pickup in the distributor that's underneath the rotor. And you can see the pickup. And this plastic cover is important. You don't want to lose it. But this is the ignition that I've chosen for basically all of my MGs and my son's. So what I'm doing is just pulling the back of this electronic ignition, CEI ignition module off to show you. And there's the magic. You see this? That's a standard General Motors 4-pin HEI module, high energy ignition from General Motors. It is the Lucas CEI ignition is really a General Motors HEI in disguise.
That's who knew. And so did they actually OEM it? Did they get it from GM? Or
yeah, they got it from GM.
That's amazing.
Or from GM's parts suppliers.
Yeah, great.
And in fact, when I put the CEI ignition in my Magnette, and the reason we didn't look at the ignition in Magnette is it's buried under the rear carburetor and kind of hard to see from a camera. But when I rebuilt that ignition system, I sent my distributor off to Jeff Schlemmer to get the advance curve set, and I went to Pertronics and got their flamethrower HEI kit to get the high-powered 4-pin module.
Wow, that's great. So that's a good combination of equipment, that it's very reliable, and so you
That
like the way
nut's
it works?
reliable.
That's incredible.
And you don't have to be changing points anymore.
Well, would you carry a spare distributor with you, or worried about the electronics box going on you, or?
When I went to MG 2016, I didn't worry about it because the worst case scenario is go to a parts store and say, I need a 4-pin module for an 84 Camaro.
Oh, that's great. That's great. All right, thanks.
This is a number 4 spark plug out of the Magnette, and you can see that the electrode has a brown coloring on it. I didn't run it hard enough to burn off everything that was on the ceramic, but you can see that it's been burning fairly cleanly, which is a good thing. If this were oily, or if it's totally black and sooty, or if it was wet in any way, I'd be really worried. But it's not. It's in really nice shape. A standard ignition is a fairly low-powered ignition because points can't take very high voltages, and so your spark plugs are gapped at 25 thousandths on a standard point ignition. The CEI ignition, the factory CEIs were using 35 thousandths. And that's what I've kept the CEI on mine. GM HEIs using that same 4-pin module were running 55 thousandths clearance for a wider flame front for lower emissions. But in our case, we don't need that because we have higher compression engines than GM was running back then. So 35 thousandths is good. Once we've got the point set, and we've checked the dwell angle, and you check the dwell angle with the engine running, you have to set the timing. Because we've got our spark plugs squared away, we got them set, they're clean. We've set the dwell angle. Now we have to set when that thing's going to fire. There's a couple of schools of thought on this, and I'll tell you, the thing that I've found to work the best is there's a standard setting at idle speed for advance on the distributor, and in a lot of cases, it turns out that it's incorrect. If you've had Jeff Schlemmer redo your distributor, he'll send you back and tell you where to set the timing at. But the better way to set it is when you get the engine fired up and run it up to about 2,500, 3,000 RPM, use the dial back on the distributor to find out what the total advance is. And so long as you're under 34 degrees or under total advance, you're the best you can be for an MGB. I like to set mine at 34 degrees, total advance. And when you do that, whatever the vacuum or whatever the timing advance is at idle is the best setting for your car.
So let's talk about the vacuum advance.
Yep. The one thing I missed when we were talking about the mechanical advance and making sure you get it oiled is at the same time check the vacuum advance. And the easiest way to do that is to just get yourself a little piece of vacuum tube to stick on the end of the vacuum advance and suck on it and watch. And if you can suck on it and watch the point plate move and move back, your vacuum advance is bad. You got to replace it. And by the way, there is a company now, name escapes me at the moment, but there's an outfit that's rebuilding British vacuum advances. So you can get your vacuum advance repaired. Now that we've got the mechanical side of it done, we've got the electrical side of the engine done, now we're finally at the point where we can start talking about carburetors. And the first thing I want to tell you is do not put automatic transmission fluid in your carburetor. Do not put 3-in-1 oil in your carburetor. Do not use motorcycle shock oil in your carburetor. They were designed to use 2050 motor oil, and that's where they work the best. The thing that I saw the most when I was a mechanic was the Strombergs on late model MGBs, because it has a rubber diaphragm in it. When folks would put those other funny oils in it, they would make the rubber swell and burst, and it would mess up the carburetor. Engine oil, it works every time. I tell you, there's one codicil to that, and that is on Volvo 140 cars that had HIF6 carburetors, like this one. The factory did calibrate it around using automatic transmission fluid. That's the only car I know of that doesn't use engine oil in the SUs. Strombergs, this may cause some pain to some people, but Stromberg carburetors I think are best used as wheel chocks. They're way too complicated. You can see this one has got a water choke for managing cold starts. It's got a rubber diaphragm in it. It's got an idle bypass valve. It's also got a rubber diaphragm in it. It's got a lot of moving parts, and they will break. And
were these designed because of emissions reasons at the time? Was that why they went to it, or
that's the only reason they went to it? Because these worked poorly enough that they would keep the emissions down, because they also sucked the performance out of the engine too. I'm not a fan. There are some people that swear by them, and a lot of Triumphs use these from the factory for a long time, and guys love them. I've never been a fan, I have to admit. Okay, let's talk about carburetors on our MGs. These are HS6s. An HS4 or an HS2 on a midget are basically the same carburetor with a smaller throat. The number refers to the number of eighths of an inch over 1 inch that the carburetor is. So an HS2 is an 1.25" carburetor, and HS4 is 1.5 inches, and these are 1 3/4. These are really overkill on an MGB, but they're still a lot of fun and they're pretty to look at. These are on an MGC, these work well. But the reason I wanted to show this to you is to talk about setting the idle speed and setting the mixture, right? Because now that we've got the car running well, we want to set the mixture to make the cleanest burn, because the cleanest burn gives me the most power. If you're on the rich side of a clean burn, that's the best. But if you want to make ultimate power, you go to the lean side, but that makes your engine run hot. So anyway, this nut down here, this is the jet, and the nut down here is how you adjust mixture. Unscrewing it lowers the jet in the bridge, and that makes the carburetor run richer. Screwing it up makes the jet go higher in the bridge, and it makes it run leaner because of the tapered needle. And when you're looking at setting the idle speed, this is how you operate the choke. The back lever here operates the throttle. You need to loosen the clamps on the throttle shaft so you can set each carburetor individually so they don't affect each other, and then adjust the clamps so they operate simultaneously after you got the idle speed set. Okay, these are HS's. 72 to 74, I guess even into 74 and a half MGs used an HIF carburetor. And that stands for horizontal inline float, because you can see, instead of having to float off to the side like an HS, the float is underneath the carburetor in line with the suction chamber. And these are, I find, to be really decent carburetors along with the HS's. These will work well. The real tricky part on these, adjusting the throttle for idle is done identically to the way you do it for an HS. Adjusting mixture is different. There's a little screw down on the bottom of this carburetor, and it has a cross slot in it, but it's not a Phillips. It requires a small straight blade screwdriver, and screwing it in richens the mixture. Unscrewing it leans it out, because it's got a bimetallic strip on the jet that is to adjust to the temperature, and so you're actually adjusting the fulcrum on that bimetallic strip when you're adjusting that screw. Okay, so when you're tuning the mixture, as we showed you, using the screws or the nut underneath, the way you know you have a good mixture is if you can use the lifting pin to lift up the jet, you'll hear the engine slightly speed up and then slow right back down to the same idle speed. If your carburetor does not have a lifting pin, get yourself a small screwdriver, because if you stick your finger in there to try to lift the piston up, you're going to disrupt the airflow and you won't be accurate. Same thing though, lifting up the piston about 1/16 to 1/8 of an inch. Listen for the speed to go up and drop back down. Another tool that is kind of handy is a color tune that is a visible spark plug, and you can't see it on the film, but it has a clear ceramic that allows you to look into the cylinder while the engine's running. And when you have your mixture set well with this device, you will see a Bunsen burner blue flame in the combustion chamber. I have to admit that using these is not as easy as it sounds, because getting the mixture right, getting the spark plug set, or getting the rest of the tool set up correctly and keeping it clean enough is really troublesome, but it's a nice tool to have. But finally, the Unisync is my favorite tool for adjusting the balance on multiple carburetor setups. With the Unisync, you use the dial in the middle to bring the little red float up to the middle of this stack, and then you make sure that all the carburetors on your engine flow the same. Now when you do that, oftentimes you will change the characteristics and have to go back and readjust mixture, and you might have a couple, 3 iterations of adjust the idle and drop it back down and get them resynchronized, adjust the mixture, readjust the idle. But if you persevere after a couple, 3 runs of adjusting mixture and idle speed, you'll get a good idle that's a smooth idle and one that's clean.
Well, do you think it's ready to start after our tune-up?
Let's give it a go. Oh, let's see, key on. On a Magnette, you have a starter button, not a switch. It's a little bit cold, but you can hear the high compression pistons and the long duration cam. What we've gone through, getting the mechanical side of the engine up, tuned correctly, getting the electrical side tuned correctly, getting the fuel system tuned correctly, is all excellent. But there's always fine tuning that you can do, and it basically depends on what's the quality of the fuel you're getting, how hard are you driving this thing. By the way, MGs like to be driven hard, so go out and enjoy and let the RPMs run.